Hope you hear me well. So hello and welcome to the Programmers Week. First of all, thank you for choosing this talk. My name is Nazar. I'm from Ukraine, Lviv studio. This is my first experience with Programmers Week, but I'm very excited to be a part of this event. I have over 18 years experience in web development. My hobby is playing the guitar and also like traveling. And today I'm going to talk about the micro-frontends architecture concept. This talk is split into two parts. First part will be more about what is micro-frontends in general, and the second part will be focused on how to implement micro-frontends with a single SPA framework. So before I start talking about the architecture concept, I would like to tell you some short intro story. Around a year ago, I started writing our project to the new frameworks, React.js on the front-end side, ASP.NET on the back-end side. So that was an amazing chance to practice with new technologies and improve our team skill. Everything was nice except the following fact. 2 years ago, this project had changed owner and now was owned by another team. So this team controlled everything, process, repository, delivery schedule. And this main team was big and had its own priorities, but my team was small and had enough independent and specific requirements. Unfortunately, we had to share a common code base, so the process was too strict and usually didn't align to our delivery plans. We had huge delays due to accepting our code and a completely uncontrolled delivery schedule. We had a real bottleneck with contributing our functionality into big application. So the both teams understood this problem and actively looked for a way to resolve it. And finally, our decision was to separate everything. So we have to separate repositories, process, host environments, and only keep a single web application for end user. It was more or less clear how to separate all of the stuff from backend side, but on SPA, I mean on front-end side, it's still be a bottleneck. And this is actually was the first time when I met with micro-frontends and where I start my journey with micro-frontends. And I'm going to explain in that presentation, so how micro-frontends help to resolve that issue. So let's begin. There are several, what is micro-frontends? There are several definitions. I like them, like maybe simplest one. So micro-frontends, it's like we have a microservices, but on a front-end side. And formal definitions, micro-frontends is an architecture style where independently deliverable front-end applications are composed into a greater whole. Bit of history. According to ThoughtWorks technology radar, this technique already passes all three phases: assess, trial, and adopt. So micro-frontends were noticed in 2016 as worth exploring technique. In 2017, this technique was marked as worth pursuing architecture concept. And just a year ago, it passed phase adopt, which means it is strongly recommended to utilize its technique, so it's ready to use. It shows really good results, provide really benefits. So comments from the repair say that they have seen many teams adopt some form of this architecture as a way to manage this complexity of multiple developers and team contributing to the same user experience. So from one side, it's like pretty fresh technology. From our side, like the first mentioned was even in 2016. And a bit more history for architecture development. So let's look a bit to different architecture concepts. Initially, web applications were written as a monolith, and even now, actually, a lot of code is written in monolith, especially when you start in a new application. It makes sense because it doesn't require too much time to write. And if you need just quick feedback from clients, from customers, so you need just to start writing some functionality and not dig into some architecture. Then splitting into the front-end and back-end side, I think it was in a time when we got more powerful JavaScript engine and it became possible to write more and more code on the front end. Web development was split into backend and front-end parts. It was time when JavaScript frameworks grew very quickly. So this was separation, horizontal separation, the front-end part and the back-end part. And after that, because we still had like just 2 monoliths. Instead of 1 monolith, we got 2 monoliths. After we got another architecture, I can say revolution. It became possible to create a small file-independent backend API, which solved complexity and scalability problem on backend side. So it is very flexible approach, and it allows to have individual teams per each microservice and to use its own tech stack. But what on front-end side? On front-end side, we have the same monoliths. So the next stage was to split on front-end side. It's the same, in the same manner. And this is how micro frontends appear. But furthermore, additional cool benefit of all this splitting on a front-end side and adding micro front-end pieces to the whole puzzle is becoming possible to build even another thing, to build vertical integrated subsystems. I think you heard already about that. So this is when we are connecting this micro front-end part on the front-end side with microservices, or small part of on back-end side, and we got some vertical slice. And as a result, this vertical slice responsible for some particular functionality, and we could have one team responsible for this whole slice. And as a result, we like got a feature-oriented team. So this is very powerful, and it that allows to this team to choose the best practices and to have experience with building some particular functionality. And so this is a great idea, but it's not required to use vertical integrated systems if you need a micro frontend. So of course you can continue just use micro frontends disconnected from microservices and have different numbers of micro frontends on the top level and microservices on bottom level, and have like different connections. So that's okay, and it's completely dependent of your current situation on a project and in your current case. But there's a great possibility to use this this vertical integrated subsystems. So what's the benefit from using micro frontends? We already talked that first of all, it's dependent teams. And I think it's the most important approach, as actually this is the main reason why we come up with this architecture concept. Smaller, more cohesive and maintainable code base. So as a result, we have less bugs, more control, easy to focus and develop. Application can be implemented in different technologies. And yeah, that's great, because one team could be more familiar with, for example, Angular. Another team could be more familiar with React. And but it's not only about using different frameworks. You can use the same frameworks for micro frontends, and you have ability to upgrade the one particular micro frontend into higher version and like test this upgrading. So this is our next benefit, this ability to upgrade, update, or even rewrite parts in more incremental fashion, as all these parts are pretty independent. And application could be a self-contained. So this is about using these vertical integrated subsystems. So, okay, this is a benefits. What's potential problem? First of all, it's consistent look and feel. Of course, if when many teams working on front end, it's a fast risk we could have. So way to resolve this risk and to minimize it is to, so of course we should have at least some communication on that level to have some consistent user experience. We should have some shared CSS style, maybe some CSS framework, use common UI components library across the teams. So should be some layers across the teams. Another potential problem is slow loading. There are like two reasons. First reason of slow loading, if we're using a different frameworks for each micro frontend, and it's like we have a bigger size of code because we have few frameworks. Like instead just one framework, we have few frameworks. So it increases the size of application. Another thing, if we have dynamic loading of application, so it takes time, especially if you have some like hierarchical loading. So when we load in one application, and this application loading own parts, so it also increases time. Duplication of dependencies. This is a problem very similar to what we have in microservices. So as we are going to have mostly separated parts, each part will be, so it's possible to have some duplicated things. And overall complexity, of course, so we should like have some infrastructure code to support this microfrontend. All right, let's look how a page with microservices could look like. So this page could be developed by 3 teams: the team product, team checkout, and team inspire. So each team responsible for some separate feature, and use even different technology. So we can look how it works on a real page. This is demo page, but it like could be demoable. So we can switch icons, click button, so it works something. And so on that page, we see that like each team focused on own problem. So each team could have the best experience in resolving own problem. And let's think now how to implement all of the stuff that we just mentioned. We need to think about some core ideas behind of that. So Michael Jers is the author of book Microfrontends in Action, and he proposes the following ideas. I have chosen a few of them. So these ideas should be technology agnostic, isolate team code, and the next idea is interesting, is favor native browser features over custom APIs. It means, so let's use for communicating and for integrating between the parts something that is already a web standard or will be a web standard soon. And his idea, so what if you try to use a custom elements from, they could be a good primitive for integration in the browser. So each team can build its components using its web technology and wrap it inside a custom elements. And so what the communication between components should look like. For communication between components, we could use some native things like a tag name, attributes, and browser events. And as a result, we see it acts as a contact or public API for other teams. It brings us to idea to use a DOM as an API. So it's very interesting idea. So, and let's look a bit closer to implementation. For example, how to build this blue buy button. So from, for example, team checkout developing this checkout button blue buy. And another team should know only about this tag with name blue buy and about some like API of this tag. So in other words, its attributes should be passed and events should be handled. This is, you see some implementation parts. And I would like to demonstrate to, let me go back to previous slide, how it could work. So let's assume I'm from another team, from product team. So what I just need to do is to what do you copy this? Yeah, so have only tag name and some attributes. And even if I inserting this from browser, it's immediately converting to a component. And I even can try how it works, and so it's fully functional. So it's, you see, it's pretty easy to use that components. Right. Let's back to the following pages. But what could be a potential problems? traditional problems is about supporting custom elements. So it's already a web standard, but it's not a fully supported by all frameworks. So it has mostly full support, but for some frameworks, it still needs some additional work. And on that side, I can show you that, for example, what support we have for different frameworks. So overall, it's a pretty nice picture. So a lot of frameworks has excellent support, but maybe, so what frameworks more? And also Polymer has mostly full support. React we see has some lack of support, so still not passing some tests. What else? Svelte, good support, yeah. So in general, it's pretty good support, but for some frameworks, like it still need a bit more. It's closing my presentation. For some reason, I didn't know. But is this just only one way how to implement a micro frontend? Only using these web components? No. So there are a lot of different ways how to implement micro frontends, because micro frontends is more like idea to have independent parts on the front-end side, and that independent parts could be developed by independent team. So it should be a separate hosting and separate some, for example, the deployment process, etc. And there are a lot of possibilities how to build micro frontends. One of simplest possibility is to use iframe. For somebody could say it's an ugly solution, but for some particular cases, it really works. So for example, Spotify uses this technique to build micro frontends, and it works. And I remember even in our projects, we also use this for some particular cases. Of course, it has a lot of limitation, and it's easy to find another bottleneck with using these frames. But sometimes it could be not a bad solution. So another way how to build micro frontends is using web components, but it's not only limited by custom elements. There are other types present also. So this is a shadow DOM, ES models, and HTML template. The following two libraries has a pretty similar name, is h-include and h-include. But second library use custom elements, similar how to web components. Project Mosaic is pretty popular. Actually, it's like a set of services, and it's created by Zalando, the e-commerce company. Open components and the single SPA. I'm familiar most of all with single SPA, as I use that framework in my project. And actually, I think this is excellent way, because it's pretty simple and it supports a lot of frameworks. So this was my first part. Maybe I'll check Q&A. This was my first part about micro frontends in general, and the second part will be focused more on a single SPA. So how to implement micro frontend using a single SPA. So what is single SPA? This is a framework that provides the abilities of micro frontend architecture, where multiple JavaScript micro frontends are possible to bind together in a frontend application. I would like to show you a part of the intro video. It brings you some highlight ideas. So it's just a short video, but it really good to understand in general. So what is it?
Enter single SPA applications. An application is a group of UI components registered to single SPA that controls part of the web page. These applications coexist no matter what framework they're written in. You might be wondering how all of this works. Once your code is registered as a single SPA application, the key is a common API made of 3 parts: a bootstrap function for initialization, a mount function that activates the application, and an unmount function that deactivates the application. Your code bootstraps, mounts, and unmounts, then SingleSpa does the rest. The SingleSpa JavaScript library hooks into your client-side routing so that at any time the correct applications are active. This might sound really hard to set up, but it's actually not. Your code doesn't need to change. You can just wrap it with some helper libraries. So how can you get started with SingleSpa? Simply npm install the library, register your first application, and call start. Welcome to microservices in the browser.
Are a technical representation of a business domain, subdomain, and they provide strong.
All right, so you just heard about some terminology, and now we will try to dig a bit in detail about the terminology that we use in that video. First is a single SPA config, in other words, is a host application where we register in all our micro frontend applications, and it should have very minimal code and minimal functionality. Main responsibility should be just to register this application. Could contain some small functionality like the header, footer, maybe. So of course it should be implemented security level, and you should try to limit as much as possible implementation on that side. So you should to bring all functionality into micro frontend applications. Applications, so micro frontend just called as applications. Actually, single SPA support few types of micro frontend. It could be application, could be parcels, and utility models. And this is a difference between each of them. Application is a recommended way. Applications, it's like some wrapper around your micro frontend that allows it easy to integrate into a single SPA. And that wrapper provide the following functions for lifecycle: bootstrap, mount, and unmount. You just saw this on a video. Parcel is a bit different from application because parcel not related to routing, and you need to determine on your own side when to show parcel, when to mount this parcel, and when to unmount this parcel. And utility models, it is also micro frontend, but without UI parts. So it uses it more when you need to share some models, but or share some common logic between micro frontends, and it should be done in a way how micro frontend works. So how to implement the host application with single SPA? The simplest code is to use register application function imported from single SPA module. So this function has 4 parameters. First is application name. Second is a loading function. It should return a promise loading function of resolved app. And the most common implementation is to use import. And third is activity function. It is a power function with location as argument and determines if application is active. And you can pass some custom props. Start function, use it to notify when application all application will be mounted, but each particular application will be decided based on route when it should be mounted. All right, so this is host application. Application. This is an example of micro frontend for application built in React. So who is familiar with React? See some things familiar to develop some application using React. So we import in React component, React from React module, React DOM, and single SPA already provide some ready-to-use wrappers that you can use for each framework. For example, for React, it will be a single SPA React function, and this wrapper you could use to wrap your component in such way that you can export that promises bootstrap, mount, and unmount, and it could be easily integrated into a single SPA infrastructure. Parcel. Single SPA parcel so using an implementation of parcel very similar to application. So it reuse the same wrapper. Only we don't pass the force parameter. So force parameter for application determines the placeholder where application will be inserted. But for parcel, we don't need to specify this placeholder. Why? Because it's a responsibility of developer determine in which place should be inserted this parcel and when it should be mounted and unmounted. So from one side, it gives like more flexibility for you to control that parcel, but from other side, you lose some already implemented functionalities that exist in single SPA. So this is recommended to use application, but if you need more flexibility, you could use parcel. And now let's look how it could be realized with some demo stuff. So I have a demo application. It uses the following frameworks: React 16 for one microfrontend, the Angular 5 for another microfrontend, and for host application they use also React, but React 15. So it demonstrates how we could use even the same framework, but with different versions. All right. Now let's look to the code. So it will be a bit development part. I have opened the 3 Visual Studios. One Visual Studio has a main application, and to another Visual Studio had the application written with Angular and application written with this is Angular, and this is this application written with React. Firstly, let's look to the host application. It demonstrates all that stuff that we just saw in presentation. So let's go to index.js. On root level, we see the 2 functions: register React function and register Angular app. This custom function. Inside we have things that we're already familiar with. Yeah, the register application function imported from a single SPA module. So we're passing application name. For React, it will be React app. We pass in functions that import our application. In this demo case, I use some custom function to load JavaScript to implement it easy, and functions that determine when we need to show this React application. So logic of working our application will be following. We have 3 roads. We have home page, we have React road, and we have Angular road. On the home page, it shows both application together. On the React page, we show only React application, and on Angular route, we show Angular application. So it demonstrates how to mount and unmount application based on routes. And you see we're describing so that we will show React application on 2 routes, on home road and on React route, right? And this function is pretty simple. So it just checks the location, path name, and compare with current location. So this is pretty simple how to determine what is current route. And very similar for Angular application. Yes, just importing app is slightly different. All right. So I can demonstrate. So this is our host application. it's run, but for now we are not loading because I didn't start the micro frontend applications. So it's not loaded this micro frontends, just showing our host application. Now let's look to our micro frontends. We will start from React. So this is how, you see, this is completely a separate application. It could be committed to an independent repository. It could follow the independent process. And as a result, it will be hosted also separately. To demonstrate that it is hosted on separate environments, I will run this application on different ports. So the host application run it on a port 3000. And our micro frontend application will be run at React, will be run on port 3002. And the Angular application will be run on port 3001. So I just demonstrate how React application is implemented. Yeah, I need to expand this a bit. So we wrap in our component with single SPA React and exporting our functions for lifecycle. So let's start and test how it works. Start in the React application. So React application disappears. And now I'm starting Angular application. And Angular application appears. So this is a home route. We have both application. Then I can switch to React route, display only React application. And when I switch to Angular route, it displays only Angular application. Cool. So that works. What can we do more? Sometimes, so of course we have this independent application, but sometimes we need to have some interaction between the parts, especially if we have micro frontends on the same page. So let's see how we can do some communication. So we have this button on Angular application. And by clicking on this button, we would like to change something inside of a React application, right? So let's go to React app. Vice versa. So I should find Angular application. Yeah. Angular application. Yeah. All right. So what we're doing? We simply dispatch an event. Yeah. So nothing special. It's just a browser event. And on the React application, we are listening to this event. And if I click button on React application, you can see that I'm able to stop or resume this timer. So it works even we have both applications hosted on different environments and integrated into a single SPA framework as a micro frontend. All right, I think this is mostly it. So let me summarize now. You can see that micro frontends actually, it is not hard. I think it's even not very complicated. It's a pretty straightforward technique. Single SPA framework is a handy utility to build micro frontends if you want to support multiple frameworks and you don't want to spend time to trying to make your all stuff be connected together. And yes, it works. This technique, if you feel your web application too big and collaboration within and between teams becomes too complicated, now you know the solution, so try it. Thank you for your attention. If you have some questions, I will check Q&A and start answering. Okay, so first question.
Yeah, I was going to say there are two questions, sorry.
Yeah, so I'm going to read the questions. First question, let's assume that we want to build a typical web-based business application using micro frontends. How should the team structure looks like in this case? Full stack, front-end devs, and backend devs. First of all, we should decide how many micro frontends we need, and it's mostly so micro frontends should be functionally oriented. So first, you need to think on what functional parts you would like to split your application, and but anyway, each that part, so each micro frontend should be enough big to have separate team. Because if you just have a few team and each team will have only like 2 person, it doesn't make sense even to split this application to a micro frontend. It only makes sense if you have a big teams. And for example, it makes sense if you have, for example, two big team and you need to split the team to an individual team. This is a way how to split functionality between team and to make these parts enough independent to develop it by both teams without much intersections. So first you need to think, do you really need, do you really have a so large functionality and you require a big team, and then think so how you need to split team based on functionality, and this team will represent their own micro frontend. So like, this is my answer. Next, how does different micro frontends share local state? Is it only via local storage, or single SPA provides some kind of Redux style framework? No, single SPA it allows to use whatever you need. The simplest way you saw, you can just send objects through events. It's not recommended to use some local storage, but for some edge case, of course, you should use. For example, in security case, you can use it for some tokens. So for some very limited thing, you should use a local storage. But the most recommended way of communication between micro frontends is using just events and passing. You can pass even some complex object through these events. Okay, the next question. What about global styles and configs? Where to save them? Yeah, so I think the best place for that is a host application. So you remember about the whole structure of that stuff. So we have host application where should be most general things, and all micro frontend application will be connected there. So the things that should be shared across all micro frontends. So of course, the logical place where to store it is a host application. So for this CSS, of course, like the best CSS should be shared across application. It should be hosted on host application, but some specific CSS, it could be placed for some individual micro frontend application. Can both applications share the same Redux state? Can they communicate via Redux? I think why not? So as I said, single SPA not limited that. So you can try. What's the best way to start splitting a monolith frontend into micro frontends? Yeah, so I already talked a bit about that. You should start thinking from your team organization. The best way, I think, to start splitting. So when I started my presentation, I mentioned that my real problem. So we had some real problem. We had independent teams, and we had a problem of communicating and collaborating between the teams. And we resolved that problem by splitting application into micro frontends. So that resolved problem of communication between the teams. So I think the main point when you decide when to start splitting application into micro frontend and how to decide what micro frontend you should use, it should be related on from your team organization, because it only makes sense if you have big teams and you have a lot of teams and you need to organize collaboration between the teams. It actually resolves that problem mainly. If you have some small functionality and just one team with few follows can handle all that stuff, you don't need micro frontends. You can just build some regular application. Okay. For the home page, does all three versions of the different libraries gets downloaded Angular and two different versions of React? What's the question? Yeah. So if you use a different frameworks for each micro frontend, of course, it will be some loading problem because it will be loaded each framework, right? There is a way, so you can reduce loading framework if you use the same framework. For example, you split your application into 3 micro frontends, and 2 micro frontends use exactly the same framework. You can optimize to use only, so it will be loaded only one time. But in general way, micro frontends it's recommend to have enough isolated frameworks. And this reason for how you should think about splitting the application to micro frontend. You should think not to split to, so you should try to reduce the number of micro frontend, because it gives some, you will have more problems than benefits. So you should have so small amount of micro frontends as possible to have a comfort work between teams. All right. If you have a shared UI library, how can you share that in order not to load it multiple times? Yeah, we did this through, so you know that, for example, in React, you could dynamically load some module, right? So it should be just the correct Webpack configuration that allow you to load module dynamically, and another web application just will load the model, the existing model. So it could be configured through Webpack, for example. So I know how it could be done for React. I believe it could be done in similar way for other frameworks like Angular and such. All right. What are the major drawbacks of the micro frontends application in your opinion? So I think you should not try, so as any architecture, you should not try to use this architecture just because it's popular and it's, so it is some buzz around this architecture, right? So you should think what problem resolves this architecture concept. And if you have that problem, you should try to apply this architecture, and but only in a way how to resolve your problem. If you don't have that problem, so you shouldn't use architectures that resolve problems it doesn't exist, right? So I think this is my recommendation. So see what your problem have and how you can resolve that problem using micro frontend. And in that case, it will help us in the best way. So that's it. I see, looks like I answered all questions. I would check chat. All right, so I think that's it. Thank you for your attention. Here are some links that I used to prepare to my presentation. And welcome to the next presentation. So today we'll have them.